So, welcome to our Ocean Acidification Community of Practice Meet the COP blog series, where we get to know a little bit more about the research and leadership team guiding our OA Community of Practice. Today, I'm speaking with Dr. Brent Else, Associate Professor at the University of Calgary. So, welcome.
Great, thanks.
So, could you tell us a little bit about your background and your interest in ocean acidification?
Yes, I'm a geographer, really. I did all my degrees in geography departments. I started out at the University of Calgary and then moved to the University of Manitoba. But of course, the nice thing about geography is that you can study many different things within that field. So I typically consider myself to be, well, depending on who I'm talking to, I might consider myself to be an oceanographer. But I've also spent a lot of time working on atmospheric processes. So I know a little bit about meteorology, particularly boundary layer meteorology. And then within the field of oceanography, most of my work focuses on marine chemistry and in particular carbonate chemistry. And to answer the question about what my interest is in ocean acidification or how I got into ocean acidification, my main field of research is understanding how greenhouse gases move between the ocean and the atmosphere, and really specifically carbon dioxide. So that's where I come at this from. Understanding how much CO2 moves between the ocean and the atmosphere is pretty important for understanding the global carbon balance. And I work specifically in the Arctic to understand how that process occurs in Arctic oceans. Well, in Arctic seas, I guess I should say. And so I'm really coming at it from that angle. I study how the CO2 gets into the ocean. And then when I was actually, I think when I was a master's student, I was working on this. And to be honest, I don't think I'd even heard of ocean acidification at that point. I think I learned about it somewhere in my PhD. And then I realized, oh, I'm working on the part where the CO2 gets into the ocean and then starts to drive that ocean acidification. So I should probably learn more about ocean acidification itself. And so I started to align my research a little bit more with that, and seeing how I could support ocean acidification studies through a little bit more of the chemistry side of things.
That's awesome.
Okay.
So can you tell us any bit about, maybe you sort of already answered this, but maybe any highlights in terms of your contributions to ocean acidification research from recent papers or studies that you've done?
Yeah, I think probably our biggest recent contribution, well, there's a few. I'll talk about a few students that have been working under my supervision for the last little while. One PhD student who's now a postdoc, Mohammed Ahmed, has published a few papers recently trying to put some numbers on how much CO2 is being absorbed in the Canadian Arctic archipelago. So if you're not sort of familiar with the geography, if you go north in Canada, eventually you hit the edge of the continent. And then if you keep going further north, there's thousands of little islands that make up the Canadian Arctic archipelago. And Mohammed's work has looked at a bunch of data that we collected over several years, measuring dissolved CO2 concentrations in the seawater from the research icebreaker Amundsen. And from that, we were able to put some numbers on how much CO2 is getting into the ocean in those areas. And it turns out that that area is a pretty strong sink for CO2. There's quite a lot of CO2 that moves into the ocean there. And we actually suspect that absorption of CO2 is increasing, or has been increasing over the last 3 or 4 decades as the sea ice concentration in that area has declined. So less sea ice means more open water. More open water means more opportunity for CO2 to get into the ocean. And that's one of the big things that he has found. And, that's pretty typical of the type of work that my research group does, really trying to put some numbers on CO2 absorption into the ocean. But I'll mention too, in doing that, we've got a little bit more involved in the chemistry. So CO2 gets into the ocean, whether or not that might be a problem for marine organisms doesn't necessarily depend on how much CO2 is in there, but more on this, more on the what we call the carbonate saturation state, which is sort of the complicated end of a long chemical equation. But I had a student working out at Cambridge Bay who was able to calculate that for the ocean right around Cambridge Bay. And he was able to do that by collecting some really detailed measurements of pH and CO2 concentration. And one of the exciting things we found there was that there's a fairly long period of time over the winter in that particular region where the seawater is undersaturated with respect to the aragonite saturation state. And we couldn't really find any other papers that have shown that for the Arctic Ocean for that depth. So this is measured in pretty shallow water. So I think that's an interesting finding, and it's one of the first findings that my research group has really like taken one step closer to understanding the potential connections to marine organisms. So that's a cool study too.
That's great. Those studies both sound really interesting. And for people listening, if you are interested in learning a little bit more about Mohammed Ahmed's research, please check out our research recap blog series for that post. Moving on to the next question, for you, I guess, why did you decide to lead the ocean acidification community of practice? You're one of the 2 co-leads of the program. So what was sort of the motivation there?
Right, good question. I come at this because I am a MEOPAR researcher. So of course the ocean acidification community of practice is funded by MEOPAR. And I was lucky enough to join MEOPAR as an early career researcher. Actually, the first research grant I ever got came from MEOPAR. So they brought me into their team that way. And I would say at that time, I was still really focused on the CO2 side of things. But the whole point of MEOPAR is to be a network. And so I met many other Canadian researchers working on these topics. And through that, got to know one of the scientific leads of MEOPAR, Doug Wallace. And when the MEOPAR leadership was trying to figure out what they were going to do next with respect to ocean acidification within the network, he approached me to co-lead the COP. And I thought that it was just a great opportunity to broaden my research in different directions. And really what we're trying to do in the community of practice is to try to bring in many different researchers and stakeholders who have an interest in ocean acidification. So I really thought, this is the way for me to get much more involved. And if you think about what I said, like when I was a master's student, just really focused on CO2 flux, knew nothing about ocean acidification. To me, this was just the next step in that journey to learn more and to align my research more with a topic that I think could be pretty important for Canada and for the world, really.
All right. Next question is, what is one take home about ocean acidification that you wish all Canadians knew?
Yeah, what I would say to that is that ocean acidification, the problem of ocean acidification is strongly linked to CO2 emissions, to fossil fuel burning. So you could think of it as kind of like an added motivation to reduce CO2 emissions. I think for the average person, you've got lots of stuff to worry about. Maybe, don't let ocean acidification keep you up at night. But if we're actively working to reduce our CO2 emissions, we'll be actively addressing this problem too. So I think that's the thing that I'd like all Canadians to know is that, if we can make progress on reducing CO2 emissions, we'll be helping out the climate change problem, but we'll also be helping out this problem too.
All right, next question. My last question for you is, what excites you most about the future of ocean acidification research?
Yeah, I think I'll answer this question kind of personally because I'm excited about certain things that our lab group is working on. I'm excited about the potential to make more measurements using inexpensive sensors. One of the biggest barriers to collecting good well, collecting large amounts of ocean acidification data has been that it's difficult to measure this with using sensors. It's typically, to measure ocean acidification properly, it's typically required collecting samples, shipping them back to a lab, and then analyzing them on really specialized instruments. There are some new sensors that are out there now that can probably fill that gap, but they're expensive and they haven't really been deployed at a wide scale yet. And I think what I'd like to see happen over the next, I don't know, 5 or 10 years is the adoption of either those expensive sensors or maybe the development of less expensive sensors, and getting those sensors out to lots of different locations, and then hopefully being able to use that to provide information that might actually be useful, again, to those operators who are worried about the health of the organism that they're working with, either in the short term or in the long term as well. So I'm really excited that we can start to use those new technologies, and if we can start to deploy them, use them sort of hand in hand with stakeholders, then I think we could really have like a big increase in ocean acidification knowledge in this country.
Awesome. That's really exciting.
Yeah,
Yeah, that's everything for me. So thank you very much for your time.
no problem. That was great.